My name is Santiago Solazzi. I'm a postdoctoral researcher at the University of Lausanne in Switzerland, and I'm a geophysicist. So, hello little fella. This is a sandstone. This is a rock sample. So first, what we need to do is to go to the field and select some place of interest where we have a geological formation. So we break up a little bit of it, or we take part of this formation from a well and we bring it to our labs. When the rock samples arrive to the lab, what we do is we cut parts of it to be able to study it in different apparatus. The geologist or the engineer or the geophysicist or the geochemist may select different parts of the rock of different sizes, and then we cut them and we make, for example, plugs like this one. It depends on what you want to study. You may have thin sections, you may have 1-inch plugs, you may have bigger samples. Once we have selected the sample, we have taken it to the lab, and once we have trimmed it to our desired experiment, we want to make a description of the rock. For example, a geomechanist or a geophysicist, it may be interesting to know what force you have to apply to break it. Okay, so the force applied is part of the mechanical description of the rock. You may want to know the mineralogy, so you want to know how much silica is in it, what is the porosity of it. So what you do is you make a lot of experiments to describe the rock from different perspectives, to know the minerals in it, to know the porosity of it, to know the permeability, to know its strength. And for that, you need a great variety of different disciplines. Sometimes we think of the experiment and we go into the field and try to find a rock to try to understand what happens in certain situations. But sometimes we do it the opposite way. We are interested in information. We perform the experiments to be able to know more about this formation. So the second option is the most common one, but suppose we are interested in studying fractures, then you go to the field and you get some of these plaques that have veins or little fractures to explore what is the composition and how strong they are and how waves travel through these kind of cores. So both options are possible. Let's try to make an example with this small sample of a sandstone. So what you do is, once you bring it here to the lab, then you try to catalog it. So as everything in a museum, also in a lab, we need to have a catalog where we can associate this particular sample that is archived in our lab to a particular formation for perpetuity if we are lucky. Once it's cataloged, you want to do some experimentation, some tests on it. So you may want to know how permeable is this rock. So one of the tests you can perform on this rock is you put it inside a kind of a vessel where you push water inside of it from one extreme and you wait for it to flush in the other side. So how much pressure you need in one side with comparison to how much water gets out gives you an amount of quantity that is called permeability. That is the interconnectivity of the pores. Okay, once you know this permeability, then you may want to model this, use this for a model. So the first thing you do is you try to see if some formula or some numerical experiment can explain your conditions, the amount of pressure you put, the amount of flow you got on the other side. And if you know that, you may be able to say, okay, the formation where this sample has been drawn reacts with such amount of flow per unit area when we apply this pressure. So that's the path, but we can do certainly a lot of other stuff. Now that we characterize somehow this sample and that we have performed experiments and then we have modeled these experiments with success, we want to do some practical, we want to use this for some practical purpose. So sandstones are known to hold water on them. Some aquifers are in sandstones, for example. Or in the context of CO2 storage, some sandstones, as the Usira sand, are used to inject CO2 on them. So what you want to do is you want to use the information of the permeability of the rock and the conductance, hydraulic conductance of the rock, to see how much pressure you need to apply in wells to generate some kind of intake of the fluids in the formation. There you go. This is the story of how you get a rock sample, you extract information from it to use it in the field for some practical applications.